What's up? I'm Mike Cefalo, and you're watching David Blanco, the next Tony Hawk. I'm a champ. You guys, yeah. Woo! Golden. Now, Dave, do you have any words you'd like to say to our crowd here before you go and shred up some mad skills?
Not really.
Not really, everyone. Any shout-outs you'd like to make before you go on this amazing endeavor?
It's Kelly McAndrews. He's a boss.
Kelly McAndrews. He is a boss?
Correct.
Boss. Tool. Boss.
Always stretch before every activity.
Ladies and gentlemen, it looks to me like David Blanco has just taken a tremendous spill. David, we would like to reach out for comment.
I think I'm okay, but I think I also just experienced Newton's first law of motion.
He just experienced Newton's first law of motion. Newton's first law, the law of inertia, states that provided there is no net force, a body at rest remains at rest, and a body in motion remains in motion with constant velocity, constant speed and direction.
Stop! Oh, that hurt so bad.
See, what Dave didn't realize was his force was not great enough to move an object of that mass. After all, Dave, size matters.
I mean, I did chip off a piece of the block. Maybe one noted that.
In contrast to Dave's kick on the curb, Pavra here has a great enough force to move the soccer ball. As you'll note, the acceleration of the soccer ball will be in the same direction as Pavra's force. He did not score. Now let's reach out to Pavra for comment.
Alright, you see, although I did not get the ball past Tim, I did experience Newton's second law, where I can kick the ball in the direction of the force.
Great. Pavra, would you like to thank anyone?
Yeah, I'd like to thank my mom, dad, all the guys here, Mr. Harrell for giving me this opportunity, and that's about it.
That's enough. In case you didn't remember, Newton's second law of motion, the law of acceleration, states the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. The direction of the acceleration is in the direction of the net force. We have an expert on Newton's second law of motion, Tim Stracula, with us, and I'm going to pass the mic along to him.
Alright, since I'm an expert on Newton's second law, we're going to put Dave back on the skateboard.
Back on the skateboard? I can do it.
So when Mike pushes David on the skateboard, he moves, but only a little bit. And when I join them and we both push, he moves a lot faster.
David fell, but that's because his acceleration was very great. And I'm here with mathematical expert Pavra to explain this to me. Pavra, do you have any sort of equation or something that can tell me why this happened?
Well, you see, Mike, there's an equation called force equals mass times acceleration. So in the first trial, when David was going slow, there's a smaller acceleration, so he wasn't going as fast. The net force wasn't as fast as the second trial. When in the second trial, there's the greater acceleration, so the net force is greater in that trial.
All right, that makes some sense. We'll be back. All right, I'm back here with Pavra for one more thing he wants to add about Newton's second law of motion, the law of acceleration. Pavra.
Mike, I forgot to add one more thing, that the direction of the net force is the direction of the acceleration.
All right, cool. Anything else you'd like to say before we go?
No, other than the fact that David Blank is a huge failure.
What was that?
Pavra!
Go down! David! Equal and opposite force are being exerted on us, so we're not moving. Okay?
Okay.
Alright.
Okay.
God, Dave doesn't know anything about physics. See, Dave's force wasn't great enough to move me, but I exerted an equal force back on him, which made him fall over.
See, what David forgot is, he didn't know Newton's third law, the law of interactions, which states, whenever one object exerts a force on a second object, the second exerts an equal and opposite force on the first.
Give me that. I was offered a skateboarding contract.
See, we're not moving because Newton's laws are found everywhere! My name's Mike Cefalo, I'm ridiculously attractive, and this is physics.